Yeah, good evening, everyone. Showing up, let's start off. Sure, let's start off with a problem. So last thing we have done this, so anything that goes in a circle will have a centripetal acceleration. So we have a string here, length L, mass M. This is going in a circle. This is theta. So this is called a conical pendulum because it forms a cone shape. My voice is clear, right? Okay. The particle of mass M goes in a horizontal circle. Find tension in the string and the time period for one revolution. Okay, so the cameras which are not on, I'll kicking you out. Okay, get the time period also. Hope you solved it or you just remember the answer. Good, good. Let's see. Ronak, I can't see you, right? Your cam is blank.
So the cam's lagging. I've switched it on. It'll take some time.
Okay. Right, Anika. Get the time period, get the time period. That's the main question, actually. Others answers? Straightforward. You always start with the free body diagram. Start with the free body diagram. Tension, mg. That's it. There are only two forces. Since you're going in a circle, there will be a centripetal acceleration, u square by r. This would be theta. This is theta. Write the forces. You get T cos theta is equal to mg, and T sin theta is providing the centripetal acceleration. So from the first one, you get tension is mg by cos theta. Straightforward. And if you take this T and put it in the equation 1, equation 2, you'll get tan theta is equal to u square by rg. But what is r here? This is the radius, which is nothing but L sine theta. So u will be root over rg tan theta. R is L sine theta. Time period for one revolution is distance is 2 pi r, the circumference by speed u. So this guy would be 2 pi r by g tan theta. R is L sine theta. You end up with 2 pi root over L by g cos theta. There. That's your time period, everyone. Check it out. So here the radius of the circle is L sine theta. L is not the radius of the circle. G tan theta नहीं आएगा निका देखो ना. I think you goofed up there. You took L as radius as L. Clear? So if you see, right, actually if everything looks like loss of motion only. The only point is since it is going in a circle, we have to put an acceleration u square by r. Other than that, the FBD, everything looks same. So this is a part. Great. So what is the centrifugal force then? All clear with this? Can I turn the page? Now listen carefully. This is important. What is the centrifugal force? In certain cases, it is convenient to solve with respect to the rotating frame. Now, since rotating frame is accelerating, it is a non-inertial frame. Therefore, we need to apply pseudo force. This pseudo force is called a centrifugal force. So, important statement here. If we use centrifugal force, don't talk about centripetal acceleration. You cannot have centripetal acceleration and centrifugal force at the same time. And vice versa. If you use centripetal acceleration, don't talk about centrifugal force. So the confusion is that then which one to use? Let me show an example. Now, which one to use? Should I use centrifugal force? Should I use centripetal acceleration? Will totally depend on you. The choice is yours. Let me show you how that works. That is the reason we say centrifugal force is Fixture's force. It doesn't exist. Hope everyone has resolved the paper. We'll see doubts today. Overall paper was easy. Let's see next paper. Mains papers only, no? Advanced papers will be tough. Paper was easy, you need to score then. Clear? Let me show an example. Now listen carefully. You got this thing, you understand what is the centripetal and centrifugal force ka drama is. So let's say we have a table here with a small hole. We have a block of mass m. And we have mass m hanging like this. So there is a block here going in a circle with certain speed u and radius r. And the other side, there is a block here hanging below the table. So the question is find the speed u if the block is at rest. Block m is rotating on a table. And the other end is connected to another block through a hole. find u if capital M is at rest. Oh, I can take like this question only. Now, let me show you one. Let us see in both the ways. You'll understand exactly what is happening. But I hope the question is clear. So first we will solve in the ground frame. Look at this, how we'll address FBDs. So when you solve in the ground frame, for the small block M, this is going in a circle. The forces are tension, normal reaction, mg. That's it. There are only three forces. And since it is going in a circle, there's a centripetal acceleration u square by r. So this is what the person on the ground will think. This block capital M, this is tension, and this is capital Mg. So from these equations, we can write T is equal to small m into centripetal acceleration, which is mu square by r. And here this tension is equal to capital Mg. And if you equate them, you end up with Mg is equal to mu square by r. U is equal to root over Mg capital R by small m. So this we used centripetal acceleration. Now, what is this centrifugal force? Now, if you solve this with respect to the rotating frame, now the important thing is, where is the observer? The observer is standing here. Are you getting it? The observer is on the block only. Now, if you ask this person to draw the FBDC, what he will do? He will say, there's a tension, normal reaction, mg. Since I'm standing on a non-inertial frame, there is a pseudo force, which is mass into acceleration. And what about the acceleration? He will say the acceleration is how much? 0. He will say block never moves. If you're standing on the block, what will you think? The block has never moved, right? The block acceleration is always 0. So this person will write the equation as tension minus the pseudo force is mass into acceleration, which turns out to be 0. So he will write T minus MAC is 0. T is equal to M into AC, which is U square by R. End of the equation will come same. This is tension and this is capital Mg. This will give you T is equal to capital Mg. Solve them, you get U is equal to root over Mg R by small. So here my observer is on the block. There. So now every time, people generally get confused that should I use centripetal or centrifugal? Ask yourself, where is the observer? So every time you solve a circular motion question, the first question you need to ask is, where is my observer? If you say, sir, ground, don't talk about centrifugal force. If you say, no, sir, I'm on the block, then don't talk about centripetal acceleration. It is at rest. You can choose any one. I hope everyone is getting this. They're not different. It is one and the same thing. So this thing that I see people getting confused, like centrifugal force, centripetal acceleration, they don't understand what it is. Nothing there. When you're standing on the ground frame, we proved in the last class that there will be centripetal acceleration. The moment you stand on the block, you think the block is at rest. But because you're a non-inertial frame, you have to apply pseudo force. Choose one. So that is your call. Which one to choose is your convenience. Generally, centrifugal force, problem solving ke liye, it looks convenient. But theoretically speaking, theoretical questions you will have problems because it doesn't make sense most of the times in ground frame. But problem solving, you'll get answers pretty well with this pseudo force or centrifugal force. Now, because it is for circular motion, we call it centrifugal force. Then I solve the same problem in both the things. Now, ask me if anyone is confused here. What is centrifugal force? What is centripetal acceleration? All clear? You can solve in either way. Go ahead, next one. And now, again, be careful. Again, one more thing, catch here. Huh? Centrifugal force, right, is not mu square by r. It depends. Let's see the next question. You'll understand. So we have a table here, omega. This is a rough rotating disk. Coefficient of friction is mu. Here you have a coin of mass m. Placed at a distance, small r. The disk radius is capital R. Okay, this will get things cleared actually. Now we have an observer here, A, on the ground. We have another observer, B, on the coin. We have another observer here, C, on the edge of the circumference. Getting it? And we have another observer here, D. Are you getting how it is? There are 4 observers. So the question is, find omega so that the coin does not slip. And find centrifugal force as seen by ABCD. So this is another misconception people have. They think centrifugal force is mu square by r and away from the center. Let's see what it actually means. Meaning you can solve this actually in all the frames. ABCD ka frame, you can solve the first part, but that is fine. Find the centrifugal force on the coin as seen by ABCD. If you look this on the top view now, this is B, this is C, this is D. So basically 90 degrees, okay? Coin is at a distance of small r, the radius of the disk is capital R. Try. The first is easy. Second part is interesting. So that is what we when you say a conceptual question, sir. My concepts are bad. People have this big issue. They think the concepts are bad because they didn't read a textbook. They'll open a textbook, they'll read everything. It feels like a novel. End of reading everything, they feel like shit. Nothing new happened. You didn't learn anything new. So this is a misconception you have. It's not like chemistry or something where you have to mug up everything. The concepts are pretty simple. Centrifugal forces mu square by r. It is a pseudo force. That is the main concept. Only when you solve more problems, your concepts get cleared. This is the what you call the paradox. You guys think what? Since my concepts are not clear, I'm not getting problems. But it is the other way around. You learned something. Let's say 100% is full. You learned 30%. You tried solving some problems. Your subject will go to 40. Now, because you got stuck, you went back and revised your theory. You came back. Again, you solved the problems. 40 went to 55. Again, you got stuck. Again, you tried few more. Maybe you got your doubts cleared. It will go to 60. Solving more and more problems will make your concepts clear. And let's be very clear. We are not here to do any PhD or any research here. We are here to crack the exam. So anyone feels, right? Most of these people misconcept. My concepts are bad. That's why I can't solve problems. Chalo, theek hai na, read everything and then start solving, right? Nah, these people are lazy. They just want to give an excuse for every damn thing. Oh, my concepts are bad. My concepts are bad. They'll keep telling this damn story, but they won't solve questions. Don't be one of them. You're getting it? You have to solve. Ho gaya? For example, this is what I did with my HC Verma. I solved the entire book once. I struggled a lot in the first attempt. Then maybe after a week or again, I tried the entire HC Verma again on my own. And second time I felt like, okay, this is what I was doing in the first time. The first time answer aa gaya tha. But I was really not clear, like, what did I do? The second time I really felt like this is what I was doing. And maybe after a month, after 6 months or something, when I opened the book and again tried those questions, I started thinking in a different way. I could have solved this question in this way also. So what matters is the repetition. There is no need to do 10 different books. Do one or two books, but do them once or twice. That helps a lot. That will make you understand better. Keep this in mind. You're really serious about improving your subject. This is what you have to do. People like to show off, huh? पता है मैंने Cengage complete कर लिया आज 400 questions. Who are you trying to show off? 400 questions, I'm damn sure he must have skipped through 50, 60 just like that without understanding. So don't fall into such traps. Fine, nice. What if he really solved 400 questions? Fine, let it be. Let him get all India first rank. You get your rank and get into IIT Bombay. Are you not happy? Why should we bother what he's getting or what he or she is doing? Let them go to hell. It should be always about you. Last time I scored 120. Did I score 140 this time? I got 140. Did I score 160 this time? The other guy got 300 out of 300. Let him go to hell. That's not your problem. So again, so the end of the story, the point is when you solve more questions, your concepts will get better. Now let's see how this thing small r and capital R. Distance is small r is the distance from the center of the coin, capital R is the distance of the disc. What does it mean? They're just two variables. You didn't like them? A and B. Happy? You can just call them anything you want. So let's solve this thing. I'll solve in one or two frames, okay? Let's solve in A ka frame. If you ask A to solve the problem, this is what he will say. Coin, friction, normal reaction, mg. This is what he will say. And he will say, since this is going in a circle, someone has to provide the centripetal acceleration. That has to be friction. There's no one else. So he will say F is equal to mass into acceleration. So this will be equal to F into u square by small r. And we know friction should be less than or equal to mu n. So we get mu square by r is less than omega, na? M omega square small r. M omega square small r is equal to mu mg. Mm cancels. So omega should be less than or equal to mu g by r. So for any speed less than this, you are safe. This is what A will say the answer is. Now, if you tell B to solve the problem, now actually exam mein to ho gaya, but I am just showing you more. If you ask B to solve the problem, so B is standing on the coin. He will say, okay, there is a friction, there's a normal reaction, there is an mg, and he thinks the coin is at rest. It's not moving only. But I know I'm in a non-inertial frame, so I have to apply a pseudo force, which is mass into acceleration, which is, I'll write this as mass into acceleration of the coin, which is m into u square by small r. So when he writes the equation, he will write f into mass into u square by small r is equal to mass into 0, because it is at rest. End of the day, equation will come same. M omega square r. Which should be less than equal to mu into n. Same story you get. Omega is less than equal to root over mu g by r. So this is using centrifugal force. So what is the centrifugal force in frame A? If you ask A, what is the centrifugal force? Which is mass into acceleration of A in the opposite direction, isn't it? And what is the acceleration of A? 0. So A will say centrifugal force is 0. Understand, centrifugal force is nothing but pseudo force, which is mass of the body into acceleration of the observer in the opposite direction, which is mass into negative of acceleration of A. A is not moving, only to 0. If you ask what is the centrifugal force as seen by B, mass into acceleration of observer B in the opposite direction, which is m into omega square r I cap. Clear? So even A will have a centrifugal force, but that is 0. So instead of thinking in terms of center of centrifugal force, think in terms of pseudo force. You'll understand better. Clear? Now look at C and D. Okay, if I ask C to solve the problem, now it is more complex to solve, but you will get the idea there what is happening. So C is here, he is standing here. What is the acceleration of C? Acceleration of C is actually how much? Omega square capital R towards the center, because he's going in a circle. Now, if you ask this person to solve the problem, he will do it pretty interestingly. He will say, okay, there is a friction, there is a normal reaction, there is an mg. Since I am a non-inertial frame, I have to apply a pseudo force, which is mass of the coin into acceleration of the observer C in the opposite direction. So he will write m into AC. This is observer C, okay, which is m omega square capital R. Because this is the acceleration of C, right? So mass into acceleration opposite to this. And he will also say this acceleration is how much? Omega square small r. He will say, okay, since I'm going with omega square r and the coin is coming with omega square small r, then relative acceleration is omega square r plus small r. This is the acceleration of the coin as seen by C. Like I said, it's more complex to solve the problem, but you got the idea. Now, if you ask him to write the equations, he will say friction plus pseudo force is equal to mass into A relative acceleration. Because this is what the coin guy will think. So this will be F into m omega square capital R is equal to m omega square capital R plus m omega square small r cancels off. We get friction is equal to m omega square r, which should be less than equal to mu mg. You get the same answer. So what is the centrifugal force here? It is towards the center. It is not away. It is not always away. And it is not always equal to mu square by r. The centrifugal force as seen by C is mass of the coin into acceleration of this guy omega square r minus I cap. It is not small r, it is capital R. Now, you can clearly see from here, if you ask D, I will not solve for D problem, but if you see this guy, D will have an acceleration this way. So if you ask centrifugal force as seen by D, that will be mass of the coin into acceleration of D in the opposite direction. That would be omega square capital R minus J cap. You're getting how it is? Or maybe I'll show it on the next page for you. But first have a look at this theta thing. C will think the coin is coming towards me with a relative acceleration omega square R plus omega square small r. So C will think there's an acceleration for a coin. There's a relative acceleration. So here the centrifugal force is mass of the coin, acceleration of the C in the opposite direction. It is towards the center. So if I ask a statement like this, centrifugal force should be always away from the center. Not true. It depends on the observer. I hope everyone is getting the hang of what is centrifugal force now. It is simply depends on the observer. Only difference here is a rotating frame. I'll just turn the page. So if you ask the D guy to solve the problem, I'll not solve, but I'll just show you the FPD. So this was a coin. You have friction, normal reaction. You have mg. So this guy ka acceleration will be omega square capital R. The pseudo force would be this way. Mass into acceleration of T. M omega square capital R. So pseudo force would be this way. This is the centrifugal force. So see, it is not even towards the center now. Centrifugal force on coin as seen by T. So again, I can write equation and solve. Answer will come same. If you just want to find omega, C and D are very bad observers. B and A are fine. But if they want to test you conceptually what is centrifugal force, don't write mu square by R blindly and come. Let me give you one more example. But I hope everyone is getting the idea of centrifugal force now. So anytime you get confused, right? Centrifugal force, centripetal acceleration, ask yourself, where is my observer? I think once you answer that question, you'll get the answer, what to do. All clear?
We could get down to the next page.
So in centrifugal force, the acceleration of the coin was actually useless. It always depends on the acceleration of the observer. Please check any doubts on this. Yasha, Vastika, clear, na? Malika, clear with this? Venkatesh, Ali, Ronak, Vidyut, Neil, Niranjan, clear with this? Neil, are you there? Neil, are you there? He's sleeping, I guess. Or is he secretly eating some chocolate? Quite possible. Let's see one more. Let's see for a minute and then we'll kick him out. Suppose if I ask you something like this. So there are two particles going on a circle. This is point A going with UA. Radius is RA. This is UB. And this is RB. So this is exactly like this. Find the centrifugal force on A as seen by B and centrifugal force on B as seen by A. This mass is MA, this mass is MB. So two particles are going in circles as shown on two different circles. Find centrifugal force on A as seen by B, on B as seen by A. Two questions. $90 degrees, okay. A and B are going on two different circles. Now, this concept, what I'm teaching you now, you tell me how many books will you read to understand this? You need to solve questions, then you'll understand the intricacies of this concept, what is happening. इतना क्यों? पूरा kinematics में how many formulas did you study? How much concepts did you study? Velocity is dr by dt, acceleration is dv by dt or vdv by dr. Three kinematics equations. बस हो गया. पूरा kinematics was that only. We did 70 problems. So don't fall into the trap like my concepts are bad, that's why I'm not getting questions. Whatever concepts you know, start solving questions. Get your doubts cleared, concepts will improve. You'll get more questions, concepts will improve. That is the way to improve your physics. You do that, and if you ask me, right, that is one of the reasons why most people, right, if you see in top 5,000, you ask them what is the favorite subject, at least 4,500 people will say physics is their favorite subject. Because subject actually becomes intuitive. So without physics, you're not going to enter top 5,000. Physics, chem is again sub rata 5. You have to ratta marne padega, even if you like or not like. So what finally decides that top 500 ka rank will be decided by max. You're planning to enter in top 500 without max, you won't get in top 500. See, being a physics teacher, I'm telling you that max is important in top 500. But pehle 5,000 to enter karne, without physics, so that won't happen. Not because, you know, max is some tough or something, because everyone loves physics. People, everyone, even the paperist of people handle physics. Neil, you're being kicked out because you're not responding. Answers everyone. I want direction also. I kept J cap. So for people who think centrifugal force is mu square by r away from the center, this will be a big slap. So first, let's find the acceleration of this thing. What is the acceleration of A? Acceleration of A is qa square by r. So if you ask this person to draw the pseudo force, what is the acceleration of B? U square by rb I cap minus j cap. So centrifugal force on A as seen by B is mass of the body ma, acceleration of the observer ab. So that would be m minus ma ub square by rb I cap. That's your acceleration, pseudo force. Same thing, centrifugal force on B as seen by A. Mass of the body you're observing, that is B, acceleration of the observer A. That would be mb ua square by ra minus of minus, it will become plus j cap. Check your answers. They're not toward the center. Clear? Everyone got this? Great. Let's see one more thing about centrifugal force. Let's see what will you guys do. So we have a wedge like this. The wedge is going, let's say, backward with V1. And we have a block here, small m. This is going with V2 in this semicircular group. Semicircular cavity, as shown. V1, V2 are velocities in the ground frame. So V1 is the velocity of the wedge in the ground frame. V2 is the velocity of the block in the ground frame. Constant. Find centripetal acceleration on the block and the normal reaction on the, find centripetal acceleration and the normal reaction of the block at this instant, at the lowest position in the cavity. This, we'll see this again in center of mass chapter. So when the block is at the lowest position, find the centripetal acceleration and the normal reaction. Wow, these two people missed out. I hope the question was clear. The wedge is going back. The block is going front. All the velocities are in the ground frame. Now let's see how much you really understood centripetal acceleration. Think. No, that is the whole point of the question. No? See, normal reaction does not depend whether you do in the ground frame or whether you do in the moving frame, isn't it? A force won't change wherever you see. If you apply 10 newtons, whether you're running or moving, it will be always 10 newtons. Force does not depend on the frame. Think, I'll give you a minute. It's a good one. show you? No, let me ask you something. When you said centripetal acceleration, remember what it was actually? A centripetal acceleration is V tangential square by R. Isn't this the actual formula? V square by R when you said. Now, when you say V tangential, what do you mean by that? V tangential is the velocity when you see from the center, isn't it? But tell me here, the center itself is moving now. So this V tangential is velocity, tangential velocity as seen from the center. It is not in the ground frame. Tangential velocity as seen from the center of the circle. Think about it. Do you think if you're standing on the ground, you think this is actually going in a circle? It is going like this and it's also coming back now. It's not going in a circle. So you tell me who thinks this is going in a circle? The person standing here will think it is going in a circle, isn't it? So that means the velocity, so that means you should see whoever thinks it is going in a circle, that guy will understand what is centripetal acceleration. So what is the V relative here? So remember this thing. This is the actual formula for centripetal. It is a velocity relative to the center. Till now, you never had a problem because center was always at rest. But now the center is moving. So this center which we have is actually going back with V1. And this block is going with V2. So V relative is V2 plus V1. So the centripetal acceleration is V1 plus V2 whole square by R. The velocity is not in the ground frame. It's a velocity with respect to the moving center. Because only this guy at the center will think it is going in a circle. No one else will see it as a circular motion. And you write centripetal acceleration V square by R, when V tangential. Then you can see it as a circle. And if you look at the forces, normal reaction, mg, since you're going in a circle, there'll be a centripetal acceleration. You can take centrifugal force also. So the equation would be N minus mg is equal to mac. So normal reaction will be mg plus m into v1 plus v2 whole square by r. There, that's your centripetal acceleration. Please have a look at this. Right, Yasha, you got that. Yasha got it right. Aryan, they messed up there, but yeah. So these are the two important things about the centripetal acceleration or centrifugal force. It is not always toward the centrifugal force is not always toward the center, and it is not mu square by r. It depends on the observer. And the centripetal acceleration u square by u is not the velocity in the ground frame. That v is the velocity with respect to the center. If the center itself is moving, you have to change. Till now, you never had a problem because center was never moving. This is an important concept. All clear, everyone? Anything you're not convinced, please ask. It's a good one. If you see, these questions are not tough, but they're easy to solve. But you need to know your concepts properly. And even if this is written in a book, and if you read this, it won't strike to you. But when you do a problem, you mess it up. Second time, if this thing comes, you will actually remember why it is wrong. So you learn actually by doing a lot of mistakes. So the faster you do mistakes, the faster you learn. And for that, you need to solve a lot of questions at home. Because if you don't solve a lot of questions at home, you'll do the mistakes in the exam. This is what my chemistry teacher used to say. I don't do so many mistakes in the class. There are none left for the final exam. So when you're actually doing a mistake, you should be happy. Good thing it didn't occur in the final exam. You got an opportunity to do the mistake now and learn. Venkatesh, you need to keep your cam on. Clear? Let's see a question. Let's do something little simpler and easy to digest. A death rotor. Name looks interesting. So we have a cylinder. I'm sure you must have seen this in a circus or something. The cars keep going and round, round, round. So we have a person here standing on the edge of this. This whole cylinder is rotating with omega. The radius is r. Mass of the man is m. And friction is mu. Okay, Venkatesh. You just have to inform me. A person stands with his back touching a rotating rough cylinder. Right? Bottom, it is open. Okay. This thing is open. There is nothing there. So what happens in this ride now? They keep the person inside, they rotate the whole setup, and they once you reach a certain speed, they remove the floor. And you'll observe people are just stuck to the walls, they don't fall down. Find omega if the man does not slide down.
Is it a weight balancing thing?
Yeah.
Okay.
Okay, everyone, just keep your heels back and head flat against the wall.
Yeah, I was gonna-
This is actually a ride in some amusement park. It's called a death.
Stay in an upright position at
No
all
place.
times, and if at any time you feel scared or sick, just alert stop, and I'll stop the ride.
Isaiah, legs
We
apart.
keep people inside and rotate.
Oh, Isaiah. Isaiah. Isaiah.
You can see the floor goes down. If you observe, right, that kidzy, even if he loses contact, he doesn't fall down. That is because the friction is independent of surface area. As long as he is touching, the friction will be same. Doesn't matter how much area is in contact.
Isaiah, you okay? Stop.
Not okay.
Isaiah, you okay? Stop.
Stop, everyone. Get
So they're slowing down.
Someone says stop. So
If you slow down, you start sliding down.
On your feet, everybody.
Isaiah. Isaiah!
And you stay flat against the wall until the parade comes to a stop.
There, that's our problem. Now save Isaiah from falling. Find Omega. So there, it actually does work. Get this easy one. Okay. Others, right. We have one answer so far. Done. Let's see. Now, again, you have to ask yourself, do I want to win the ground frame? Do I want to win the relative frame? I always ask that question. Don't directly jump into the question. You guys have that problem. You guys think, you know what? You guys don't solve a question. You don't plan for the question. You see the question, you try to write on the paper. That is the reason why you are slow. Because for a moment, ask yourself, okay, it's rotating. So am I doing it the ground frame or relative frame? Just ask that to yourself. It will take 3-4 seconds. But this will help you a lot in the exam because you won't get confused. When the problems become complex and you start getting confused, that is because you don't have a proper framework in your mind. You don't ask yourself, you don't talk to yourself. That is the biggest problem. Not only in physics, but in life also. Biggest problem people have, right? You ask them what they want in life, they don't know. You know why? Because they don't talk to themselves. So ask yourselves, okay, am I doing this relative frame, ground frame? When you ask questions to yourself, you will get answers. But if you're just staring at the question, you don't get. And this is a very important line of thinking, asking questions to yourself. Because when you ask yourself, you're trying to find out. Most people think, you know what? They ask question to others and they just wait for them to tell the answers. You're like, it's like spoon feeding. That won't help you. That will not make you strong. It's like, I think I told you this thing. I'm sure everyone has a close friend or a best friend or something. I think I asked you this, but think about it. If I ask you, tell me 3 good things about your best friend. You can tell me 3 good things about your best friend. I'm sure, tuck, you'll get the answers. Right? Tell me 3 bad things about your best friend. That also you might find. But same thing if I ask you, tell me 3 good things about yourself. 3 bad things about yourself. You will notice something here. About your best friend, the 3 good things, this will come very fast. And 3 bad things about you will come very fast. These 2 are very fast. The other 2 will take time. Ever noticed that? We know more about others than us ourselves. You know what your best friend wants, more than what she wants or he wants. That is because you talk to them a lot, you don't talk to yourself. So how do we do this thing? I will do it in the ground frame. You can do in the relative frame, doesn't matter. After this, I'll stop doing in both the frames. For now, I'm showing you both. Generally, for problem solving, centrifugal force is better, little convenient. So normal reaction, friction, mg, and since you're going in a circle, centripetal acceleration, which is omega square r. We get n is equal to, so here normal reaction is providing the centripetal acceleration. F is mg, which is less than equal to mu n, so mg is less than equal to mu omega square r. So omega will be greater than equal to gr by mu. So as long as the speed is greater, you're safe. If you do it in the rotating frame, that means my observer is on the head here. Normal reaction, friction, mg, centrifugal force. R will be in the denominator, yes. During this time, I should tell. I'm checking you guys. You are. And the story is same here. N is m omega square r. Friction is equal to mg, which is less than equal to mu n, and you end up with the same answer. It doesn't matter which frame you take, answer should come same. It is just a matter of convenience which frame you want to do. Exam method do one. Clear? Easy? Next one. This next question is quite important, comes in at least 6 chapters. You can put a star for this. Circular motion comes again in surface tension, elasticity, waves, magnetism, electrostatics. 6 chapters. So we have a ring here. Mass m, radius r. Rotating with omega. This is the top view. Standard question though. If you look at the side view, it would look like this. So because the ring is rotating, it will generate tension in the ring. Find tension in the ring. Let me show you this, how to do. Because there's a certain way to do this. See. Listen carefully, this process. It is the exact same process you have to use in other chapters also. We take a small piece here, d theta. This arc length is rd theta. So this is a very small piece here. So this, if you take half, it will be d theta by 2. Forces will be tension. Forces will be tension. If you look at this angle is 90. So this guy will be d theta by 2. So if you take the tension component, this will be t sine d theta by 2. But the horizontal component is t cos d theta by 2. T cos d theta by 2 and t sine d theta by 2. And this will be the centrifugal force, which is dm omega square r. So the two sine components are balancing the centrifugal force. Now what is this dm? dm is the mass of that small piece. So mass by total length. So total mass of the ring is m and the total length of the ring is 2 pi r into the length of that small piece is r d theta, which is m d theta by 2 pi. In case you're confused with that, unitary method. For 2 pi r length, mass is capital M. For r d theta length, mass is dm. Substitute here. One more approximation. For small angles, sine theta is approximately equal to theta. I hope everyone knows this. You know this thing. Remember, theta should be in radians. Huh? So in one batch, I taught this thing. So someone is like sine 3 degrees is 3. So like the problem is that. So sine 3 degrees is not 3. Suppose if it is sine 3 degrees, first write this thing as sine 3, 1 degree is pi by 180. So this is approximately equal to 3 pi by 180 or pi by 60. That is the meaning of this. Don't write 3. So substitute here. So this will be 2t. For small angles, d theta is very small. So you'll get d theta by 2. dm will be m d theta by 2 pi omega square r. 2 will cancel. D theta will cancel. We end up with tension is equal to m omega square by 2 pi. Now this is like, you should know that I have to do this way. Exam mein to strike nahi hoga these kind of questions. But this is a standard one. Comes a lot. So you should know like, okay, I should approach this problem this way. Result is important, but more than that, the process is important. Do have a look at the steps what I did. Neil, are you there? Now there, what happened? I think people were spreading rumors that you ran away and all. So people were saying you went to eat a Nutella or chocolate. You want to know the truth. Okay, we had Wi-Fi issues. That's a very gentle way of saying it. But the truth we know. You went to eat Nutella. There, it is the one who's spreading rumors. It is not me. Clear with the question? Quite an important one. Huh? You should definitely know this thing. You know, how will this question come? I'll just show you. We saw this thing in there. This is a chapter called surface tension. So it becomes a ring and all. So you will see here. Then you will see in a chapter called elasticity. You will see this in multiple places. You will keep seeing this ring of Fanda. So don't forget this thing. Put a star. Star questions are either standard or something which will repeat in a lot of chapters. That's the best part about physics. You learn few concepts will keep repeating. That's the best part, and that is the deadly part also, because you mess up one, you'll mess up all the things. Clear with this? So if you observe something here, did you observe when something rotates pretty fast, the tension is what omega square means. If you increase the rotating speed to double, the tension becomes 4 times. So this is one of the major problem, you know, when you're designing what you call sports cars and all. Did you ever see on your vehicles you have speedometer and side में एक RPM का meter होता है, 5000 RPM, 6000 RPM. That is how fast your this thing, you know, the rotation is. So now just imagine if the rotation goes from 1000 RPM to 10,000 RPM. We are talking about the tension increases by 100 times. So when you have such high rotations, right, the axles can crack. Now normal Mumbai mein cars ka to not a problem. We don't go that fast. Right, but when you go for sports cars and all, when they reach speeds of 180, 200 kilometers per hour, the stress on these materials can be so high, the things can crack inside. So you can't use your regular metals. We have to use, you know, special alloys which can withstand this kind of tensions. So when I was in IIT, na, third year, second year or third year, during that time, right, we didn't have what do you call this USBs and all. USBs are very expensive. 1 GB used to cost to around 2,800 or 3,000 rupees. Very expensive. In 2007, with 3,000, मतलब बहुत expensive है. So we used to use DVDs. Each DVD can withhold around 4.2 GB का data. I used to have around 100 DVDs. Books, movies, cartoons, games, सब होता था उसमें. So that was like our hard disk. It's like big box. So people used to show off. देखो मेरा पास 3 boxes है घर पे. So one day I was going out and someone was selling DVDs. 7 rupees का एक DVD. I was like, you're dead cheap because a DVD costs you normally 20 rupees. So I brought 2 DVDs. I brought them to the room and I kept them in the DVD burner. So we call the process burning, putting data on it. So this way, you have limits. You can burn the data at a rate of 2 Mbps, 10 Mbps and all. So the faster you burn, the faster the disk will rotate. As usual, being lazy people, I kept it the fastest speed. So it started burning and after 10 seconds, fart karke, there's a big sound. I just switched off everything. I opened it. Inside the disk was broken into pieces and powder ho gaya tha, some part of it. I literally had to clean the whole PC. I was dead scared like PC kaam karega, nahi karega. Luckily it worked. The second DVD, I gave it to my friend as a gift. So obviously, meaning I remembered that you have to share with your friends. So I said, yeah, take it. My beautiful friend, you need to have this. And then this is the thing what happened. So when you rotate something pretty fast, things can be very bad like this.
Interesting pieces. The critical spin rate of a CD is 23,000 RPM. Hopefully we'll be able to achieve that and film it like 500 and the power. I think it's about to go.
So if you are taking a DVD, rotating at high speed, and they're recording with a high speed camera. So this thing is like, this thing can record up to something like 170,000 FPS. That's a pretty high rate. So I think you can see on the left hand side, it is like 2,500 FPS.
So as you can see from this, 2,500 frames a second
So how it
isn't
shattered?
nearly fast enough to see what happened there. Look at it, it's moving, like the whole thing. Whoa! Oh my god! Oh man, that looks amazing! Literally just shattered into tiny little bits. It's just like physics don't know what to do in the CD. It's just like, nope, no, I'm gone, I'm out, I'm done. Oh, that's amazing! See that again? Amazing. At 720, full speed. Full speed ahead. Warp drive on. Okay. Oh. This is satisfying to turn. Is it? Yeah. Oh!
It just goes off like a balloon.
You can actually see it warping. 90 frames a second. You, the actual moment where something happens takes forever to get to. Yeah. Oh! That was awesome because you saw the actual shape of the CD and the cracks in it were perfectly like.
Did you see where it started cracking? On the corner. Why? Tension is m omega square r by 2 pi. Bigger the radius, more the tension. So the outermost circumference has the highest tension. So that is where it is cracking.
The direction the CD was spinning. It was like a spiral effect on the CD. Like a turbine. That was cool. Alright, so that was at 62,000 frames a second. Giddy.
So this thing, so the camera is so good, it just recorded 4 seconds, but the frame rate is so high, it takes 7.5 hours to watch the whole thing. It's a 6 GB file. 4 seconds ka recording is 6 GB. So it's a very high frame rate. That kind of camera will cost you almost 1 crore. A high-speed camera will cost you 1 crore. So there, so discs can be shattered if you can rotate them fast enough. One other thing that happens in vehicles, especially sports vehicles, when you design them, you have to be careful about engine and all. They're just not about putting steel and all. They can't withstand such kind of stresses. Clear with this? Let's see one more question. So we got a rod here. Mass M. length L. The whole setup is rotating with omega. So this is x is equal to 0, x is equal to L, neglect gravity. Find tension in the rod at a distance x. Get this. Can you tell me which point has the highest tension? Which point has the highest tension? Think like this. If you take centrifugal force, this viscous centrifugal force this way, this way, this way. See, every point has a different centrifugal force. At this point, all of them add up, right? The axis will have the highest tension. So this free ends will always have zero tension. Remember this. This is a free end. Because there's nothing else to hold it, right? There will be no tensions. So that you can remember. Free ends always have zero tension. Because there should be something there to apply tension. There's nothing there, so free ends will have zero tension. So T is zero on the corner. So get this. That is a mistake you did, Asha. Limits ka mistake hai tera. This is also important. We will see this again in fluid mechanics. Similar question. Try, I'll give you a minute. Listen how we take the limits. Limits cube na re. Now, the process is important. Huh? See, these are the new things, okay? You guys have not seen this kind of things before, how to integrate, how to take elements. So these things you should remember, okay, when I get something like this, I need to take elements like this. No matter how much I say, yaar, physics सोचना पड़ता है, there are some parts आपको रट्टा मारना ही पड़ेगा. You know, mugging up stuff is the foundation of learning. But problem क्या होगा ना? People don't think after that. They think सब mug up कर लेते हैं. For example, the previous question, if you see, you need to know the process. No matter how much you think it is very difficult, it will strike on your own. So look at this thing, how we do. At a distance x, take a small piece dx. So when you take this small piece dx, if you look at the forces on them, there is tension on the left-hand side. So this is the tension due to this rod. There's a tension on the right-hand side, T plus gt. and the centrifugal force dm omega square x. So basically you're treating this small dx like a particle going in a circle. What is this dt? dt is the change in tension due to dx. So as you go a little forward, assume the tension changes by small amount dt. Change in tension for dx thickness. That is one. Second thing, people think like, sir, if tension is decreasing, why are you taking plus dt? Now, mathematically, when we solve, the science will take care of it. You should not worry about it. Mathematically, we always assume functions are increasing. Not only here, later on when we study pressure, any kind of quantity, we assume functions are increasing. That is, we'll assume t is always increasing with x. So even though you know it is decreasing, you don't do that. You put it, the science will take care of it. We assume functions are increasing. That is, t increases with x. That's why you should take plus dt. So write the forces there. So we'll get t plus dt plus dm omega square x is equal to t. Tt will cancel. We get the change in tension is minus dm omega square x there. Our assumption is right. Actually, tension is decreasing. The sign took care of it. And then you're done. So dt is minus what is dm? Mass by length into dx omega square x. I hope you remember what is dm. dm is total mass by total length into length of that small piece. Integrate. Now here, this is where people do mistake, okay? Tension goes from 0 to t, but where is the tension 0? Tension is 0 at the free end. So limits hoga L to x. Don't put 0 to x. Because when x is 0, tension ka value you don't know. The limits are not always 0 to t and 0 to x. When tension is 0 at x is equal to L. So if you solve this, I get t minus m omega square L x square by 2. Limits will go from L to x. So tension would be m omega square by 2L into L square minus x square. There, this is your tension as function of x. Have a look at this. Some of you messed up the limits, but this is the proper process of getting it. Take a small piece. There are 3 forces on the small piece. Don't forget. एक centrifugal force and 2 tensions है. There is a tension due to the left part of the rod, and there's a tension due to the right part of the rod. And there's a centrifugal force on the small piece. Have a look at this. Ask me if you're confused. Whatever we did today, right? We did a lot of conceptual questions, and I showed you 2-3 different formats how to handle questions. You should definitely try these questions without seeing them once more. The word is without seeing them. So look at the question, try to solve. You'll get stuck, then go back and see it again. All clear with this? Any doubts on this? Clear? Next one. Next one. Turning the page. There we have a system like this. So we have a rod like this, rotating with omega. So this is 90 degrees. Here you kept a spring, mass M. This length is L. The natural length of the spring is also L. And the whole system started rotating with omega. I hope the diagram is clear. So the question is, find the elongation in the spring. When it, meaning it's rotating with omega, once you start rotating with omega, find the elongation in the spring. So initially this length is also L. Spring constant is K. So basically this thing can go only, this mass can go only along the rod. Mass can move along the rod. It can't fall down, up and down. So I hope the diagram is clear. You took an L-shaped rod and you connected the spring from here. So let's call this thing O, B, and A. So the spring is only from B to A. Get this? Just give it a try. Let some water and come. Let's see. Root omega square. No. Maybe that's not the answer. No, that is not the answer, Yasha. See, you guys are drawing the FBD wrong. What is the radius of the circle? See, let this length be L. Let elongation be X. So this length will become how much? L plus X. This is the radius of the circle, R. This guy is going in this circle, na, radius r. So centrifugal force will be like this, na, m omega square r. Centrifugal force will be away from the circle. So if you take this angle as theta, remember this is 90 degrees, so this is theta. And if you look at the forces here, this force will be spring force kx. And this centrifugal force the component will be m omega square r cos theta. I hope you're getting the diagram there. So centrifugal force will be radial direction. Uska component will pull the spring and that will be equal to kx. Spring force is k into elongation. So we get k into x is equal to m omega square r cos theta. But what is r cos theta? So in this triangle OAB, this is theta, this is r, and this is this. So r cos theta is L plus x. We get kx m omega square r cos theta is L plus x. Bring x to one side and shift everything that side. We get m omega square L by k minus m omega square. Check, that's your answer. I think the mistake you guys are doing now, you're not considering L plus x. That will change the radius of the circle, na? It is not L root 2. Check your steps. Clear, everyone? Let's see if I have block of mass M.
Sir, can you go back for a minute? Thank you.
Masses, identical masses. This length is L. So this block is given speed u. One block is given horizontal speed u. Find the acceleration of the blocks at this instant. We can't find after some time, but at this instant we can find the acceleration. Get this easy one. What are the forces acting on the system? mg. Now, next moment, you'll start going in a circle here. You also have a centrifugal force, mu square by L. And this is also mg. Acceleration, acceleration. This is not exactly right, but it works. If you try to do it in a normal way, it becomes a little complex, meaning we have to keep the observer here. So this guy will think it is going in a circle. So we have acceleration will be what? Remember, net force along the string by total mass. Net pulling force method. We have done in NLM. The only difference is because you got a horizontal velocity, you get a centrifugal force now. mu square by L plus mg minus mg by total mass 2m. U square by 2m. Easy. mg is already there. Now you got an additional centrifugal force mu square by 2l and the total mass is 2m. Clear with this? Turn in the page. This I'll give you as a homework. Try and come. We have a disk and we have a rod. Mass m. Length is r by 2. So this rod is placed along the radial direction. And this whole setup is rotating with omega. And the disk is also rough. It's a rough rotating disk where the coefficient of friction mu is equal to mu naught into x square. Friction constant nahi hai, where x is the distance from center. So means as you're going out, it is becoming very rough. At the center, friction is 0. As you go radially outside, friction becomes smaller and smaller. So find omega max. Find omega if the rod is about to slip. Find tension in the rod as function of x. X is the distance from center. Make sure to try this. Is the question clear?
Sir, can you show the 19th one for a minute? Yes, sir, thank you.
Next one, we have a groove like this. If you see this in the top view, you kept the ball here. This is r by 2. And the total radius is r. So this is a smooth groove. There's no friction anywhere. Find the speed when it comes out of the groove. try these two questions. So make sure to spend some time on this. Second is fine. First is also fine. They're not that difficult, but yeah, you have to do some integration and stuff. So next class, first thing in the class, we'll be discussing these two problems. So try and come. I won't give you time in the class. So I'm giving you time now so that you can try at home for some time. So, okay. So with that, we'll wrap up for the day. So do try them. So next week again, we'll catch up on Wednesday as usual. And next week we'll finish off this part. We will finish off banking of roads and stuff, and we'll do non-uniform motion introduction also. So now we will take where the speed is not constant anymore. Okay, so with that, we will wrap up for the day. So some people had doubts in the paper last time, so you guys can stay back. Those who have doubts, you can stay back. Others are free to leave.